Hello everyone, welcome to PYQ'S. We are doing fluid mechanics. This is first lecture. This question came in IS 2014. Find the equation of motion of a compound pendulum using Hamiltonian equation. Now, if you know about these equations, it's okay. If you do not know, then you have to study because there is no other way. So learn इसको आप उतना ही सीखो जितना कि आप एग्जाम में क्वेश्चन करने लायक हो जाओ. So now I'll tell you something here. You can derive it forward for another questions. So in this question, it is given that there is a simple compound pendulum. There is a compound pendulum which is given by this. Suppose this is the compound pendulum. Here is the center of mass of compound pendulum. Let mass is mg. Let it O be the origin. Then let this is at distance h, and this is being theta. Then moment of inertia of this compound pendulum can be written as m into k square, where k is radius of gyration. K is radius of gyration. And kinetic energy, kinetic energy can be written as half I omega square. Then this can be written as I m k square. Omega को हम लिख सकते हैं theta dot square because omega equals to theta dot. Okay. Then potential energy of this can be written as potential energy V. You can see, suppose V equals to 0 here, then it is going downward. This distance is h cos theta. So V will be minus m g h cos theta. So moment of inertia is this, kinetic energy is this, and potential energy is this. Now for Hamiltonian equation, we know we have to first check the Lagrangian. And we know what is Lagrangian. L equals to Lagrangian is equal to T, that is kinetic energy, minus V, or you can, this is kinetic energy, be denoted by T. So from here we can see that T is equals to half m k square into theta dot pi square, and minus, and then again a minus, so plus m g h cos theta. Now you can see Lagrangian does not depend on T. अगर Lagrangian T पे डिपेंड नहीं करता तो हमारे पास एक थ्योरम है जिसमें ये कहते हैं कि Lagrangian अगर डिपेंड नहीं करता T पे तो Hamiltonian जो है वो कांस्टेंट होगा और वो इक्वल्स टू होगा टोटल एनर्जी ऑफ system. You need to learn these things. Just only these two things you need. अगर Lagrangian T पे नहीं डिपेंड करता है तो Hamiltonian टोटल एनर्जी ऑफ सिस्टम के इक्वल होगा. और अगर आप एक और पार्ट इसमें है जो कि हम आगे बताएंगे कि कैसे इस क्वेश्चन को सॉल्व कर सकते हैं. Then we will write H equals to T, total energy of system, T plus V. So H equals to T plus V. Now you can write T from here. You can write T from here. Here it is T and here it is V. So I'll write T from here, m k square theta dot k square, and minus V and dh cos theta. So this is H. Now we can see that generalized coordinate theta is only generalized coordinate here. तो आपको पता है कि थीटा खाली जनरलाइज कोऑर्डिनेट है, तो आप जो जनरलाइज कंपोनेंट ऑफ मोमेंटम p थीटा उसको लिख सकते हैं dly d theta dot से partial differentiation of Lagrangian with respect to theta dot. You can find partial differentiation of Lagrangian, then partial differentiation of this with respect to theta dot. ये तो इसका differentiation होगा और ये होगा 0 theta dot के respect में. So I'll get partial differentiation as m k square. Then you'll get 2 theta dot and 2 will be cancelled. That will become theta dot. Okay. Now we have to find h. Now we can write this h. Now we can write this h in form of p. This h in form of p and theta. So h equals to half. Now we'll replace this theta dot. This theta dot will be replaced from here. From here we'll get theta dot equals to p theta upon m k square. Now if you put theta dot here, we'll get p theta upon m k square of whole square, and then I'll write remaining portion mg cos theta. Now mk square cancel, so what we'll get? We'll get half p theta ka square upon mk square or minus mg h cos theta. So this is the equation. Why we have represented this in the terms of p theta? Those who know the two equations of Hamiltonians, they remember that we need to represent it in the form of p theta or theta. So we need to represent it in the form of p theta. So now we'll write from, wait a minute, from Hamiltonian equation, there are two Hamiltonian equations. One is p theta dot equals to minus del h by del theta. Then we can differentiate this with respect to theta. We'll get, by differentiating this will become 0 with respect to theta, and by differentiating this we will get minus mgh cos theta. Cos theta ka differentiation, that will be sin theta. Okay. Now this equation will become this. Now we have to find out, you know what we have to find? We have to find the equation of motion. So equation of motion is generally in terms of acceleration directly proportional to some displacement. Generally this kind of equation there is for equation of motion. So we can find theta dot from Hamiltonian equation, which is equals to del h upon del p, generalized coordinate of momentum theta. So there are two equations. Hamiltonian two equations are there. One equation is this, p theta equals to minus del h by del theta, and del theta is equal to del h upon del p theta. So these two equations are used together. Now I differentiate theta dot and Hamiltonian. That here is Hamiltonian. I have to differentiate it with respect to p theta. So what I'll get? I'll get p theta upon m k square. So I'll get p theta upon m k square from, again we can differentiate it again because I have to remove anyway p theta, but here we have p theta dot. So differentiate it again with respect to p theta. I'll get p theta dot upon m k square. Then put this value here. Then put this value here. You'll get minus mgh sin theta upon m k square. You can get cancel m and m. Finally we'll get minus mgh sin theta upon k square. So final required answer is required equation of motion हो जाएगा, वो होगा थीटा डबल डॉट इक्वल्स टू माइनस जी एच साइन थीटा अपॉन के स्क्वायर. दैट इज रिक्वायर्ड आंसर. अगर आपको ये चीज़ें पहले से नहीं आती हैं तो आपको बेसिक वीडियो कहीं से देखने पड़ेंगे या फिर मेरे वीडियो तक बनाने तक का इंतजार करना पड़ेगा. दैट इज फ्रॉम माई साइड फॉर दिस लेक्चर. थैंक यू.